All right, let's dive straight into this explainer. You know, we send and receive money literally every single day, right? But how often do we actually stop to think about the invisible machinery making all of that happen? Well, that's exactly what we're going to do. We're pulling back the curtain on the complete payment lifecycle, tracking a transaction from the very millisecond it's initiated all the way to its final irrevocable settlement. Because honestly, to the customer, whether that's you buying a coffee or a massive corporate treasury team, it usually just looks instant. Boom, done. But beneath that surface, wow, it is an incredibly intricate ecosystem of validations, compliance checks, and risk assessments, all furiously at work. Behind every successful transaction, in mere milliseconds, dozens of systems are talking to each other in real time just to make sure that money moves securely, accurately, and of course, legally. So here's our roadmap for the explainer. We'll hit the illusion of instant payments, then dive into the payment engine's validation core, navigate those tricky cross-border flows, unpack cutoffs and value dates, look at the ISO 22002 data revolution, and finally tackle the global interoperability challenge. Okay, kicking things off with part 1, the illusion of instant payments and how speed really comes down to geography. See, domestic rails like India's UPI or FedNow in the US, they give us this amazing illusion of instant, borderless money. They're running on these unified, API-driven ecosystems where settlement is pretty much real-time. But cross-border flows? Totally different story. The second a payment crosses a border, it leaves that nice, unified ecosystem and gets dumped into a deferred, really complex, multi-hop correspondent banking plumbing system. So while true RTGS, real-time gross settlement, is incredible domestically, those deferred multi-hop models are still the absolute reality for most of the world. Moving on to part 2, the payment engine validation core, essentially the brain of the whole operation. Now, inside that engine, all of this happens in literally milliseconds. First up, pre-processing. This is where it's hunting for duplicates and running vital AML, anti-money laundering and sanctions checks. Next, step 2, core processing and smart routing, where it automatically picks the optimal payment network. Then step 3, the actual provider authorization. And finally, step 4 wraps it up with post-processing and settlement. It's this beautifully orchestrated sequence that guarantees secure routing. And for massive B2B or government use cases, getting this straight-through processing right is absolutely crucial. A really vital concept inside this engine is earmarking. Basically, earmarking is temporarily reserving funds before the final debit actually goes through. Think of it kind of like reserving a specific seat on a train before the journey even begins. It acts as this invisible safety net that prevents settlement failures down the line. If you're on a treasury team managing liquidity, knowing exactly when funds are just earmarked versus when they're actually debited, yeah, that's everything for accurate cash forecasting. All right, part 3, navigating cross-border payment flows, or as I like to call it, the friction of borders. So when moving money internationally, a lot of people just assume, oh, SWIFT moves the money. Well, actually, scratch that. SWIFT only securely transports the messages. The actual liquidity, that moves through correspondent banking accounts, specifically Nostro and Vostro accounts. A Nostro account basically means our account with you, usually held in a foreign bank and currency. A Vostro account is your account with us, held locally. These accounts are the actual physical plumbing. It's where the money physically sits and settles, while the SWIFT messages are just the instructions telling them what to do. And when money is hopping between all these accounts, fee deductions are a big deal. For corporate treasurers dealing with B2B invoices, you absolutely have to understand SHA, hour, and BEN fee models. If you pick SHA, the costs are shared. If you pick hour, the sender covers the whole shebang, so the beneficiary gets the exact invoice amount. But if you choose BEN, the beneficiary is paying all the fees, meaning they get the lowest net amount. Choose the wrong model here, and you are looking at short-paid invoices and an absolute reconciliation nightmare. Which brings us to part 4, cutoffs, value dates, and liquidity, the invisible clock. Every single payment is fighting against hidden deadlines called cutoffs. It's exactly like the final collection time at a post office. Miss it by 1 minute, and your letter is sitting there until tomorrow. Let's say you initiate a payment at hour 0. That's your trade date. Hour 1 is your processing date for those AML checks. But the actual interbank exchange of funds, the settlement date, that might not happen until day 1. And the most critical piece, the value date, when the beneficiary can actually use the money, might be day 2. If you miss a network cutoff, this whole timeline shifts, delaying that value date and totally throwing off your cash forecasting. Because of these strict timelines, treasury teams have to be incredibly strategic about currency value types. Cash, or SDV, gives you T0, same-day settlement, when you are in a massive rush. TOM is T+1, or next day. Spot is T+2, and that remains the industry standard for cross-border transactions. So lower T values mean you get much faster settlement, giving you liquidity exactly when you need it. But as you might guess, it usually comes at a much higher premium cost. Moving to part 5, the ISO 20022 data revolution. This is all about creating richer, transparent journeys. Listen, ISO 22002 is not just some boring formatting update. It is a total revolution in data richness. We're mapping old legacy formats into structured XML messages, and suddenly the whole life cycle is crystal clear. A customer kicks things off with a pain.001 message. The banks then talk to each other to transfer the credit using a pax.008. The beneficiary gets their notification via a cant.054. And if something hits a wall, a pax.004 handles the return. Having this super structured, specific messaging provides the exact data B2B environments need for automated, straight-through processing. And look, exceptions happen, right? But when they do, this rich data is a lifesaver. You really need to know the difference between a repair, a reject, and a return for reconciling accounts efficiently. A repair means there's a data issue. You fix it, and the payment keeps going before settlement. A reject means it failed validation completely and stops dead in its tracks before settlement. But a return, that PAX04 message we just mentioned, that means settlement already happened, and the funds literally have to be reversed and sent back after the fact. Tied directly into all this modern transparency is the UETR, the unique end-to-end transaction reference. Think of it as a globally unique digital passport, or like a GPS tracking ID for your money. With a UETR, a treasurer can track a cross-border payment anywhere in the world, across any intermediary bank. It finally answers that extremely stressful question of where is my money with absolute certainty, dramatically reducing investigation times. Finally, part 6, the Global Interoperability Challenge. This is the future of liquidity. So, the biggest hurdle right now is how we actually connect all these massive systems. For decades, institutions built these point-to-point bilateral API integrations. But honestly, that model just doesn't scale. It creates daily reconciliation nightmares and drains resources. That point-to-point plumbing is dying out. To achieve true interoperability and RTGS efficiency globally, ecosystems have to embrace unified central hubs. You integrate once, and boom, you instantly reach everyone. Pairing those central hubs with rich ISO 2022 data sets us up for the real future here, an intelligent, fully autonomous payment lifecycle. We're talking about systems predicting failures before they even happen, using AI to just automatically pick the absolute best payment rails. Self-healing failed transactions without a human ever touching them. It's going to be an ecosystem that actually learns from every single transaction to dynamically balance cost, speed, and success rates. Which leaves us with a pretty provocative thought to chew on. As we roll out all these new standards and centralized hubs, are we fundamentally innovating the life cycle of payments, or are we really just making the old plumbing run faster? It's a huge question for the industry to figure out. Anyway, thank you so much for joining this explainer. I really hope this deep dive demystified the payment journey for you, and I'd encourage you to keep rethinking how the financial liquidity of tomorrow is truly going to flow.